Welcome to Civil Engineering. This is tutorial part 2 for complete structural designs of wires on CSI ETABS software. This tutorial part includes 3 basic points. The first point is that how to calculate wind pressure coefficients on the roof. This is the final spreadsheet that we are going to use to calculate the wind pressure coefficients both in leeward and windward direction. So I will show it in detail. So the second point that this tutorial part covers is how to decide live load for the roof based on the codal preference. And the third basic point is that how to assign all possible loads on the roof. In the previous tutorial, that is tutorial part 1, we have seen that how to define material and section property, how to model this project. If you have interest, check the link in the description box and first comments of this video. Watch this video up to the end to master structural designs of industrial building with 30 meter span steel truss. Thank you. Let's dive into today's tutorial. As a reference, all of you must know this basic point. For this purpose, let's open Eurocode. So Eurocode page 46, I have to get this types of roof, that is door pitch roof. From this door pitch roof, I have 2 types of door pitch roof, that is when the angle become positive and when the angle is negative. So I have these types of roof. So from this, when the load applied to the x direction, that is to theta is equal to 0 degree and to theta is equal to 180 degree, we have this arrangement. And when the load or the wind load applied to the y direction, we have this types of arrangement. But the basic point from this to know the load direction is that first you have to know the half of your roof, that is the through or your radius. For example, from your model, go to this model, then this is the ridge, that is the halves of our truss or the center parts of the truss. After that, starting from this, you can know the directions of the load or the mechanism of the proportion here. So by considering this basic point, for example, let's proceed to our project. So I will show the load calculation mechanism of this. That is when apply the load to perpendicular to the ridge, that is the wind applied in this direction. Before proceeding to calculating all these wind load coefficients, let's go to first define all possible load combination and load patterns. To do this, let's go to the define menu. From the define menu, load patterns here. From this, we have different load patterns that I have defined before. So to know more about this, I have upload a video. So you can use this video link in the description box and first comments of this video. But in our case, let's proceed to use wind load patterns. So let's edit it. So from this, let's go to wind in the x direction. So modify this wind pattern. From this, it's better to use exposures from shell objects. This is because our project is a shell, that is a gas shell. So from this, let's go to wind coefficients. From this wind velocity is nothing but it's a recorded velocity data from 10 meter heights of a building within 10 minutes. So from this, go back and check European norm of standard or your local building code of standard. But in our case, it's better to use 22 meter per second. The other wind coefficient is that terrain category. From this European norm of standard defines 5 terrain category. Let's go to the Eurocode and check all these terrain category type. Eurocode has this 5 terrain category. From this 5 terrain category, it's better to use category 2 in our case. This is because area with low vegetation such as grass and isolated obstacles, that may be trees and buildings with separation of at least 20 obstacle heights. So it's better to use this in our case, but depends on your project location. You can use category 0 if your project is located in around coastal or sea areas, or category 4 if your project is located around the town, and so on. You can read more about this. So let's return back to our project. So it's better to use category 2. And the other factors are orographic factor. This actually depends on the slope. So let's go to Eurocode and check this factor also as numerical calculations of orographic coefficient. From this actually depends on the slope. In our case, orographic factor. Let's use flat area. So orographic factor is 1. And turbulence factor in the structural factor, that is CSCD. It's a recommended value from the code. You can go back and check it. Recommended value is 1 for both turbulence factor, that is K1, in the structural factor, that is CSCD. You can use this recommended value. Air density depends on the altitude. In most cases, it's 1.25, so it's good. And the other point is that exposure height. So the exposure height is better to use from base to the truss top. After this, make it okay. So in similar way, you can define to the wind directions to the y direction also. So it's better to check this. That is exposure from a shell object. After that, you can change in similar way like this. So make it okay. After defining all possible load patterns, make it okay. After that, let's go to calculate all the wind pressure using this from European norm of standard, that is page 46. That's around page 46. It's all about door pitch roofs. From the door pitch roof, we have two types of roof. That is when angle alpha become positive and angle alpha become negative. The roof looks like this. After that, the wind pressure, when the wind pressure is applied perpendicular direction to the ridge, that is the mid parts of our truss. So all the arrangements looks like this. Let's go to the Excel spreadsheets here. So from this, I'm going to apply wind load to the larger direction, that is perpendicular to the ridge or the through or the center of the truss. So the larger direction is 56 meter and the smaller direction is 30 meter. Let's go to the project and show all these data. This is the spacing between these two consecutive columns is 8 meters. So 1, 2, 3, 4, 5, 6, 7. So 7 times 8 is 56. And the spacing between these two consecutive columns is 7.5. So 1, 2, 3, 4. 4 times 7.5, you can get 30 meter. So using all this data, apply a wind load to this, that is perpendicular to the ridge, that is the center of the truss. So let's go to Excel spreadsheet and calculate all these wind coefficients. The first point I'm going to tell you is how can get E value and B value. B value is nothing but it's the opposites of the wind that apply, that is the suction phase. So B is equals to 56 meter. So B is equals to 56 meter, that is opposites of the applied load. So after knowing this B, let's proceed to calculate the value of E. The value of E is nothing but E is equals to B or to H. So from this value, you can take the smaller one. So B is equals to 56 meter. But what about to H? To H is nothing but it's 2 times the heights of our project. To know the heights of the project, right click here, add or modify. From this modify story data. So the total heights of the project is 11 meter. From this, let's calculate the value of E. So to H, that is to H is equals to 11 times 2. From this 2 value, let's go to select the value of E. That is the smaller value. That is E is equals to 22. Using this data, you can calculate all the portions of this roof. So you can divide E over 4 here and then E over 10, E over 10 around this. So using all this data, the portions of or the area of F, G, H, J and I respectively is calculated like this. After calculating all these data or all these portions of areas, let's go to calculate the angle, that is make it elevation. So from this, you can calculate this angle as tan theta or tan alpha is equals to opposite, that is 2 meter divided by the adjacent, that is 7 meter plus 7 meter, which is 50 meters. So using all this data, you can calculate the angle as 7.5 degree. So using all this data, you can use the CPE value, that is external exposure coefficient. First, it's better to go to the Eurocode here. From Eurocode, for theta is equals to 0 degree, that is the wind perpendicular to the ridge or to the x direction, that means. So you can use all this data. So our angle is 7.5 degree. It is between 50 and 5 degree. So you can interpolate between this, but in tutorial purpose, this is the value of 5 degree. All of you must give attention here to know the value of CPE, that is the pressure, external pressure coefficients. So to do this, let's go to the Eurocode here. So the Eurocode for wind in zone for wind direction, that is theta is equals to 0 degree. So from this, we have CPE 10, that is external wind coefficient 10 and external wind coefficient 1. So how to use this wind coefficients? If the area, that is calculated area, is greater than 10, you can use CP10. But if the area that is you have calculated is less than 1, you can use the value of CP1. But if the value of the area that we are going to calculate is between 10 and 1, let's have a formula. You are interested, write in the comment section. All of the area that we are going to calculate is above 1. So it's better to use the value of CP10. So from this, the value of CP10 is taken as like this. So as an example, let's take the value of section that is F. So from section F, let's go to Eurocode. From the Eurocode, CP10, because its area is greater than 10. So from this, let's go to use the value that is the angle 5 degree. From this, it's better to use minus 1.7 and 0. So you can use this value. You can use this value minus 1.7 and 0. In similar way, you can use all these values for all of these partitions. After that, let's go to select the maximum pressure coefficient, that is the maximum external pressure coefficient. I will tell you one basic point before proceeding to the next step, that is starting from the ridge or the through or the centers of our truss. That means at this point to the left direction, that is the area of F, G and H. It's exposed to both suction and pressures, but to the right of the ridge, that is J and I, only exposed to suction load. So using this principle, let's go to divide this as this part as both suction and pressure, and this part, that is the parts of J and I as suction portion. After that, it's better to select the maximum external pressure coefficient. So from all these data, the maximum pressure coefficient, that is minus 1.7 as suction. Let's proceed to the other data. So that is the pressure coefficient. From this, I'm going to use only the angles of 5. So from as I compare this angle, that is 7.5 degree to 5 degree. In case of 5 degree, the applied pressure wind load is decreased. So in our case, it's better to interpolate. So if you interpolate these two values, that is 0.0 and 0.2, you will get 0.1 average value. In a real design case, it's better to interpolate in a calculator. So using all these values, the maximum negative value is 1.7. So take it as 1.7. And the maximum external pressure coefficient, take it as 0.1. That is the positive one. The area or the portion of J and I, the only load is that the suction. That is the internal pressure load through windows that apply towards or from the internal to the external face. So using all this principle, let's go to calculate the maximum external wind coefficient. So from this, let's select the maximum wind coefficient as 0.6. So from this, let's proceed to calculate the internal wind pressure. So from Eurocode, internal wind pressure. So from this, let's go to one formula, that is mu. Mu is equals to the summations of area of opening where external pressure coefficient is negative or zero, that is to the suction direction, that means divided by the summations of area of all opening. If you know all about the openings, you can use this graph, that is you can calculate the value of mu like this. After that you can use this graph. If you have not any data to calculate the value of mu, you can use the governing of one of these two values, that is 0.2 and minus 0.3. So using all this data, I will show the calculations of the internal wind coefficient. So from this, let's use internal wind coefficient 0.2 and minus 0.3. From this, let's go to calculate the net wind pressure, that is net wind pressure is equals to external wind pressure minus the internal wind pressure. From this, let's go to calculate it. So make it is equals to here. So the maximum external wind pressure is this. So minus this value, you can get minus 1.9. And from this, let's go calculate and check from this value. So I'm going to use or I'm going to select the governing one. So from this, let's go to this value minus this value. So it's minus 1.4. So neglect the direction. This is because the direction is how to apply the load only, but use the value as it is. So the maximum net external pressure, that is the suction load, is this. So from this, the maximum pressure, that is 0.1, is calculated like this. So from this formula, let's use is equals to sign. After that, the maximum external pressure, yes, minus this value. So you can get this value. In similar way, you can calculate to the suction part. So this is at the right directions of the reach is calculated as like this. So using all this data, let's go to apply all these loads to our project. So let's proceed to assign all these net pressure coefficients to our project, that is a suction load of 1.9 and pressure of 0.4 to this area, that is to the wind direction, and at the back or at the suction zone, a suction pressure coefficient minus 0.8. Before proceeding to assign all this load, let's check the load patterns again. So from this, go to define menu, load patterns. So from this load pattern, I'm going to assign all the load to the y direction. So from this, let's check the wind as the wind in y direction as wind pressure, and the wind in y direction, but it's a suction. It's a suction for the suction load. So make it the wind type as the load type as wind, and Eurocode 1. So after that, make it that. So let's modify this load. So from this, let's use exposure from a shell object. So wind velocity. In similar way, let's check as 22 meter per second. After that, all the data is similar. So make it okay. So the wind pressure is applied toward this direction, that is toward the y. So let's select all these shell objects. Then I'm going to show you how to apply all these pressure coefficients. So first, let's select all these shell areas. You have select up to the center, so up to the ridge, that mean. So you can select easily like this. After selecting all these slabs that we are going to assign this pressure coefficients carefully like this, you have to know more about the local axis direction. So to do this, go to the set display option here. After that, object assessment. So let's select this, or let's select the local axis, make it okay. After that, the local axis direction is appeared like this. So the blue line is to the upward direction. That means for the pressure, to attain the pressures, you have to make a negative to apply on the this surface. So let's go to check the value. So the value of the pressure is 0.4. So to apply this load, go to assign menu. So go to shales or shale loads here, wind pressure coefficient. So from this, select wind in the way, that is for the pressure. So from this, you must select windward direction. So the local axis direction is to the upward, that is the blue direction. So you have to make a negative sign, negative 0.4. After that, make it apply here. Wind coefficient is applied like this. Change to the suction, yes. After that, check the value of suction, that is 1.9. To attain the suction load, it's towards the local axis direction, so you have to make positive. But the only difference is that make it leeward or suction direction. After that, go to the select here, get previous selection. So all the previous selected slab is selected like this. Make it okay. Click one slabs here, go to load. So the wind pressure, that is windward direction, and the wind pressure that is to the leeward direction is applied like this. But in case of the suction zone, that is the zone around this, or in 3D model at the backs of the wind direction, or at the backs of the ridge. So you can assign this calculated value, that is a wind coefficient of minus 0.8, that is a suction load, in a similar way. So you can assign it like this. But the last basic point is that how to know about the live load that we are going to apply on this roof. Eurocode recommends that a live load of 0 to 1 kilonewton per meter square. So that is depends on the slope. So in our case, our slope is 7.5 degrees. So for a slope less than 30 degrees, you can use a live load of 0.6 kilonewton per meter square. So you can apply to the negative direction, that is towards our shell. So you can apply in similar way, but the dead load is calculated on the software by itself. These were the most important part regarding to load calculation, load attain, and load combination. So in the next tutorial part, we are going to analysis and design this project. Thank you so much. Goodbye.